Welcome to trigonometry. That's basically triangle geometry. It's a branch of math, geometry in particular, that just deals with triangles alone. So we'll be seeing a lot of triangles. Everybody is quite familiar with what a triangle is, I expect. The most basic definition would be a polygon with three sides. We'll look at some other properties of triangles that are really cool and sometimes most people don't pay attention to. The first one is that they are the smallest polygons. So you can't have polygon with less sides than a triangle. So you can have a two-sided polygon in that sense. You could try to draw one. Put this here and try to put another one. You see, you can't make a polygon. You would need a third side to be able to complete the shape, to close up the shape. The second property is that it's half a parallelogram. Half of a parallelogram. That means that if I take this triangle and I double it, maybe I put another equivalent triangle to this on the other side, I would get a parallelogram. Let me try to do that so you can see. I'm just trying to redraw. More like I flipped the triangle and I put it on its head. I have the exact same triangle, and look at that. We have a parallelogram, parallel sides here. We have two pairs of parallel sides. Next is the area of a triangle. So the most basic formula is derived from the area of a parallelogram. Area means the amount of space on a shape. The formula for the area of a parallelogram is base times height. You would expect that since a triangle is half a parallelogram, then they have the very popular formula, that's half times base times height. So half of the area of a parallelogram. Some people just say BH over 2. Whichever one you does is fine, it's good. Next is the perimeter. The idea of perimeter again is the distance around the shape. So if I try to walk around a shape, how far would I go? How far would I need to go? So the formula is really simple. It's basically adding up all of the sides. If this were A, B, and C, and I needed to walk around the yellow triangle, my perimeter would just be A plus B plus. Final property of triangles that we're considering is the fact that the interior angles are supplementary. Supplementary means that they add up to 180 degrees. That means if whatever this angle is, this angle, whatever they are, or they could be, if you add them up, you would always get 180 degrees. That's quite a useful tool because sometimes you have just two angles. Say we have this as 40 degrees and we have this as maybe 20 degrees, and we're trying to find what this is. Since we know that they must add up to 180 degrees, we can just make, like a math equation. We could say 40 degrees plus 20 degrees plus x gives 180 degrees. 60 degrees plus x is 180 degrees. Collecting like terms would end up with x is equal to 180 degrees minus 60 degrees. So x is 120 degrees. Right? And that's easy enough. So always try to remember this word supplementary. Is going to pop up in your quizzes, and that the sum of the interior angles 180 degrees. Okay, here are some triangles. I'm sure if you look around you, you'll find a number of shapes that are triangles. Much of our work on trigonometry would actually be based on a special kind of triangle called the right triangle. So the right triangle is special in the sense because you have one right angle, 190-degree angle there. Let me point that out here. This one here, and for this triangle here is this one here. So these are your right angles here. The second property you would expect is that two angles are complementary. So the other two interior angles are complementary. Complementary means that the angles add up to 90 degrees. And you would expect that because if all three angles should add up to 180 degrees, this is 90 degrees, then that means that what you have left for the other two angles here is 90 degrees. So x plus y must be 90. The acute angles must add up to 90 degrees. So let's hold on to this word, supplementary. Supplementary means add up to 180 degrees, and complementary means they add up to 90 degrees. Next property is that a right triangle is half a rectangle. So if I play the same trick I played on this yellow triangle, if I play it on the right triangles, I would get rectangles. I should flip this and put it on this side, I would have this. Perfect. Don't laugh at my drawing. Okay, I could try to do the same for this other one. I don't think I'll be as lucky with this one, but I'll just try to get it as perfectly as possible. Okay. Not bad, actually, not bad. Okay, so we played the same trick here, and you can see we have, another triangle. The final property of right triangles is that the longest side is called the hypotenuse. You would really need to look out for the hypotenuse because it's very useful in all of the other properties and rules we'll be learning as we go ahead. So you need to be able to pick out the hypotenuse of a right triangle. It's the longest side, like I said, so that would be this, the hypotenuse here for this white triangle. Sometimes you might not easily see it, so I also recommend that you just look out for the side that is opposite the 90-degree angle. So like this is your hypotenuse here. And for this one also, this is your hypotenuse here. This is your hypotenuse. All right. I guess that's it. The other two things I will just mention are Pythagoras theorem and SOHCAHTOA are rules that we use to work around right triangles. So we'll be doing a lot of work on these two rules. I call them the two big rules, and they'll be foundational for every other property or every other concept we're going to do in our study of trigonometry. Thank you, and I'll see you in the next video.